Welcome back to Maths with Mrs. J. We've been talking about linear functions and we've been talking about the fact that they always graph in the form of a straight line. We have some understanding of gradient. We should also have some understanding of the special cases where we have a horizontal line or a vertical line. In general, a linear function tends to be written in what's referred to as the gradient y-intercept form. The coefficient of the x will be the gradient and the c will be your y-intercept. Bear in mind, if you've got minus a number there, then of course your y-intercept will be negative. There is another way that's quite common to write straight line equations, and that might be written like this. Ax plus by plus c is 0. This one is given in that format. So usually it's either in that format or that format. If it is in this format and you want to find the gradient and y-intercept, it does require a little bit of rearranging using your algebra. You can also use the gradient y-intercept knowledge to take a line that you can see and find out what the equation of that line would be. So we're going to work on 3 examples now and see how we go with our y equals mx plus c. Our first one's nice and easy. We've already got it in the form y equals mx plus c. So the gradient is going to be 2 and the y-intercept is going to be -3. Now, how you would use that information to plot it, you would start off by plotting your y-intercept down at -3. Now, a gradient of 2 is really 2 over 1, isn't it? Or you could think of it as 4 over 2 or 6 over 3, whatever. So if you're using 2 over 1, you want to have a run of 1 and a rise of 2 before you get to your next point. So then we're going to draw a straight line that goes through those 2 points, if we can. Let me just rearrange that a smidge. There we go, and we're just going to write our equation on the line. So y equals 2x minus 3. So start with your y-intercept, then use your gradient. Here's your rise of 2 and your run of 1 to give you a second point that you can use. There are other ways of graphing straight lines that we will look at, but if you're using gradient and y-intercept, this is the way to go. This one here, as I mentioned, is another fairly common way of seeing your equation of a straight line. If you want to use gradient and y-intercept, you're going to have to get it into this format. So let's get rid of our -5y by adding it to both sides. And of course, you can change the order and say, well, okay, well, 5y is 2x plus 10. That's perfectly reasonable. Now we're going to get rid of the 5. To get rid of the 5, we need to divide both our terms by 5. Now we're in a position where we have our y equals mx plus c, and we can go ahead and do our plotting. So we start with our y-intercept at 2. Now our gradient is 2 over 5. That means we need to be able to represent a run of 5 and a rise of 2. So here's our first point, that's our y-intercept. Our other point would be, or one other point of an infinite number of points, would be at 5, 4. Then of course we get a straight line and we join those up together like that, and we can write our equation on our line. So this is 2x minus 5y plus 10 is 0. Of course, that line goes infinitely in both directions, and it consists of an infinite number of points where 2 times the x value minus 5 times the y value plus 10 will equal 0. Let's go back the other way and go from a graph to the equation. Well, we can see pretty clearly from here that our y-intercept is 1. So if we're using y equals mx plus c, c clearly is going to be 1. How are we going to get our gradient? We'll pick any other convenient point. This is a convenient point because we know the values there. And let's work out our rise over our run. So your gradient is rise over run. In this case, our rise, we've gone down by 1, and our run, we've gone across by 2. So when we pop that into our equation, we just get y equals -1/2 x plus 1. And it's perfectly fine to leave it in that version. If you don't want fractions, you could multiply everything through by 2 and pop it all over the one side, but that's perfectly fine